Hello, students. Here's a little bit of a hint for you for assignment 3.4 on this ionic bonding preview. The main thing that you want to make sure that you're doing is answering these first 4 questions. I'm going to give you a hint for the first 3. So the first thing you've hopefully already done is you've gone through and you've clicked on this ionic bonding simulation website where it's going to bring you to this interactive animation on ionic bonding. You would have clicked launch right here, and then you would have opened this ionic bonding tutorial. So as you're reading through the tutorial, don't just skip through. If you're tempted initially to just like skip through, go through and read. I encourage you also to read this stuff out loud. Reading stuff out loud is also an opportunity for you to hear it, but also speak it, and not just hear it in your head. So as you're continuing to go through each of these slides, you cannot move forward unless you interact with the tutorial. So you want to make sure that you do that as you're continuing to work on this. When you get towards the end of this tutorial or the end of this simulation, you'll get to what is the ratio of calcium ions to fluoride ions in the model at the end of the simulation. You should have gotten a ratio of 2 calcium ions to 4. No, you had a +2 and you had a -1. So you would have had a ratio of calcium ions would have been on here. I'm gonna, again, similarly to the tutorial I made the other day, increase the size of my image here. And you would have ended up having 2 fluoride ions to every 1 calcium. So the ratio would be 1 to 2. Or if you were to answer this, you could also have a 1, you can write it in the ratio format. You would have 1 to 2, 1 to 2 calcium to fluoride. So that's what you would have for the answer for number 1. And that's after you've had a chance to kind of go through the tutorial and see how it works for the ratios. And then the final formula for what the molecule was supposed to be for calcium and that fluorine bond, or when you end up with calcium fluoride, you would end up having a CaF2. That would be your answer for number 2. And then number 3, use what you know about Lewis structures, valence electrons, and behavior of elements on the periodic table to explain why calcium and fluorine bond the way that they do. The definition really is that every element, every atom on the periodic table wants to gain 8 electrons, except for helium and hydrogen. They're the exceptions, but the octet rule is going to be the main reason that there's going to have that bonding happen, because those metals, they want to get to this ideal state of having 8 electrons on their outermost shell. If they give away some electrons, they're going to have 8. So they're going to give away their electrons, either 1, 2, or 3. There's more in other cases, but for this class, there's either going to only be metals giving away 1, 2, or 3 electrons. And then those other atoms on the periodic table, those non-metals, they're going to be stealing them. They're going to have that group 7, they're going to steal 1 electron. Group 6, they're going to steal 2 electrons. Then you have group 5, they're going to steal 3 electrons. So that's really what it's going, they're always trying to get to that magic number 8. So that's going to be giving you the direction of number 3. And then number 4 and 5, number 4, that's something you can add to as you're going through the simulation. And number 5 is if you want to do a screen cap of that model, the 3D model of calcium and fluorine. So if you have any questions, please continue to reach out.